Welcome to another Python lesson here in UG Academy. As if you have watched my previous video, you may notice that I'm previously using Cantonese to teach Python. However, I decided to switch to English in this lesson. If you're curious about why, you may have a look at the comments. I have written down the reason there. So, the topic for today's lesson is about object-oriented programming. If you have experience with object-oriented programming in other programming languages, then this shouldn't be difficult for you. But if you have no experience in object-oriented programming, it's also okay. Because the object-oriented programming of Python is very typical and it's easier to understand. So, the first thing of object-oriented programming is about creating objects. So, how can we create objects? Before we create objects, we need to create a prototype for the objects, and that is what we call class. For example, we create a class called person. That means we intend to create a type of objects called person later on. Now we are writing a prototype for it. Before we create a person, we have to call the initialization function. The initialization function is a function that it initializes the object's attributes. The attribute of an object is just some property that describe the objects. For example, in this case, we write a function def init underscore underscore init underscore underscore bracket self comma name. This is the syntax for the initialization function. If you have experience in other programming language, it's similar to other programming language constructor. Now here, self is actually a class of person itself. Later on, you'll see why this is important. And then name is another attribute that passes to this initialization function. Now, after in this function, we call self. It's actually this attribute. Then we assign the name parameters to an attribute also called name. Beware that this name is not equal to this name, because this name here is the parameter being passed into this function, and the self here is actually referring to the object itself. We use self.attribute name to assign a variable to an attribute of the function of the object of the class. And then, in addition to the name attributes, we also create an HP attribute, which refers to health. Like we are intending to create a very, very simple game. So this person needs to have some kind of health. Now, since it's object-oriented programming, an object must be able to perform different behavior. This function only allows me to initialize the data attributes of the objects. Then we can create other object or instant function for this class, and then it can perform different kinds of behavior. For instance, we create this shout function. For all instant functions, we always pass in the self arguments as the first parameter, because we will often use the attributes that come from selves. So for this function, for demonstration purpose, it will be very simple. We just print out the name of the object itself, self.name, and then we also print out another string called like this. That is what I mean by self short that. Other than this, we also like to create another class called monster. Similarly to the person class, we will also have an initialization for the monster class. For the monster class doesn't have name, so we simply initialize the attributes using a constant here. So we don't pass any parameter into the initializer function. Then we are going to add some object function or instant function in this class of monster. First, we create this laugh function. It prints out monster, haha. It's similar to the shout function here, but since the monster doesn't have name, so when we print it, we simply call it monster instead of using an attribute specialized to that object. Then, since we are going to create a very simple game, we also like this monster to be able to hit the person. So we add a hit function here. Since object-oriented programming is about different kind of object interacting with each other, so it's common to have another object as an argument. Here, this hit function will take in a self argument, which is common to all instant functions, and then it also take in another person argument. This person argument is an object of person type, and then it will be being hit by this monster. We have to be aware that for class we often start with a big character, but for variables we often start with a small character. So this person here is an instance of this object class of this person class, but not the class itself. If you don't understand the relationship, it's okay. We'll demonstrate the relationship between a class and an object later. Now, as you can see, since the monster is hitting the person, we should reduce the health of that person. The health of that person is defined here, and we can access the attributes of the person within the monster hit function. Minus equal, that means it reduces this amount from this variable. The self.power attributes of the monster defines how hard it could reduce the health of the person. Then, since the person is being hit, we would like it to shout out. It's very natural, right? When you're being hit, you may shout. Then, after the person shouts, the monster itself laughs. So it called back a function defined previously, the laugh function here. So we have created two very simple classes for our game. Now, let's create some objects from these classes. As I have said, classes are really just prototype. Itself are not objects. We have to instantiate an object from a class. For example, m equals monster. Monster here is a class. To create an instance from the class monster, we have to call the initialize function, which is like this. Add a bracket after the class monster, then it will return an instance of the class monster, and then assign it to the variable m. So m is now a monster. Now we create another variable p, and let it be a person. Like similar to the monster, we create a bracket here, but since the initialization function of person requires a name variable, we have to pass a name for it. So let's pass it as Peter. Now we have created a monster object and created a person object. Let's see how many health do this person have. Just a small reminder here. There is a semicolon here. However, since semicolon will result in the end of string, so we type this / here to escape this semicolon. If we don't type this / here, it will treat it as the end of the string. Yes, and you can see there's an error here. So in order to tell Python that this is not the end of the string, this is within the string, we have to escape this semicolon. So add a / here. Then it will understand that this semicolon is part of the string. See what will happen. The person's health is 10. As you can see, because we assign 10 here. No. We assign 10 here. Yes, self.health equals 10. Now, how about if the monster hit the person? M is the monster here, and then we call the function hit. This function is also called a method of the object. Yeah, the object function can also be called as method. Then we pass in the parameter person here, and then m will hit person. After the hit function is performed, we again have a look at the health of the person. So initially, the health of the person is 10, and then now the monster hit the person, and then the name of this person is called Peter. We pass it here, and Peter said and then the monster is like haha, because we define it here. After the person shouts, the monster will laugh. So after the function ends, we again look at the person's health. It becomes egg because it gets hit by the monster and is being reduced here. So of course the person may take another name because we just passed it here. Like if it is called Mary, then the person that say I will become Mary. It just depends on the name attribute of the person. Defined here and printed out here. I hope this tutorial demonstrates a very simple object-oriented program and very simple program written in an object-oriented fashion. Of course, there is still a lot more about object-oriented programming, but this tutorial gives a very brief overview of how class is created and how attributes and methods are defined. Later on, we'll look at other topics in object-oriented programming, for example, inheritance and operator overloading. See you next time.